A logarithm of a number to base x in this case is the power to which x must be raised to give the number. The laws of logarithms here, we have this law of addition. When you add two logarithms with the same base, that is base a in this case, it's going to give you log base a of x times y. You multiply the numbers. For example, in our example here, we say that log of 6 base 4 plus log base 2 base 2 of 2 base 4, because it is base 4 the same base, we multiply the numbers, so it's 6 times 2 giving us log base of the same base, or log of 12 to the same base 4. We are subtracting two logs that are having the same base. We divide the numbers. In this case, if it is log of 8 base 8 minus log of 4 base 8, it's going to simply be log of 8 divided by 4 of the same base, 8. And here we get log of 2 base 8. So let's explore some other laws that we need to know. We have log of x base a. If x is to the power n, this n, it's the same as saying that n multiplied at the beginning of the logarithm, so it's going to be n times the log of x base a. If the number and the base are the same, if log of 5 base, it's log of 5 base 5, the answer is always equal to 1. If it is a log of 10 base 10, the answer is always equal to 1. If it's a log of 20 base 20, the answer is always going to be equal to 1. And also, the log of 1 to any base is always going to be equal to 0. Log of 10, if it's a log of 1 base 10, it will be 0. If it's log of 1 base 20, it's going to be equal to 0. It's important that we know those principles at our fingertips. So let's explore the relationship between logarithms and indices. And we have an example, a random example here that converts log of x base 8 to indices. Now converting this to indices means that it's going to be 8 to the power 5 is giving us x. So in essence here, the value of converting this logarithm to indices is going to be 8 to the power 5 is equal to x. As simple as that. Let's look at another random example here. Log base, if log of base of x base 10 is equal to find the value of x. Now here, to find the value of x, it is as simple as first convert it to index form. So it's going to be 10 to the power 2 is equal to x. 10 to the power 2 is equal to x. So the answer we shall get here is going to be x is going to be 100. And that's the answer. So that is converting a logarithm into an index form. Change the base. For example, if you're having log base 10 of 5 is equal to y, and we first convert that to index form. So by converting it to index form, it means that to the power that is equal to that. So it's going to become 10 to the power y is equal to 5. And so now we want to convert this logarithm to base 2. So what we do here, we multiply both sides by log base 2. When we do that, it shall become log base 2 of 10 to the power y is going to be equal to log base 2 of 5. So of course this y is going to come down there from our laws. This is the same as saying y log base 2 of 10 is going to give us log base 2 of 5. When we divide both sides by log base 2, log of 10 base 2 over log base 10 of 2, we shall end up with y giving us log base 2 of 5 over log base 2 of 10. So there we have changed that logarithm. We have changed this log of 10, log of 5 base 10 has been changed to base 2. So in essence, if you look at this, the nature here, this logarithm, it was log base 2 of 5. So it's going to be log base 2 of 5. Divide that by log base 2 of 10. Log base 2 of 10. So if we wanted to change this logarithm to base 5, it will simply be log base 5 of 5 divided by log base 5 of 10. If you want to change this logarithm to base 6, it will be equal to log base 6 of 5 divided by log base 6 of 10, like that. So this introduces us to another law. When we want to change the base, change of base, that is how we do it. If we want to change log of a base b to base c, it's going to be log base c of a divided by log base c of b. That is how it comes out. So we shall do an example here. Log of 6 minus x base 4 is going to be equal to log of x base 2. So now here the lower log is 2. So we start with our calculation. So we try and we convert this to base 2 so that we harmonize. We have both sides having the same base. So converting this base to logarithm to base 2, we are going to apply our just concluded law. So here it will be equal to log base 2 of 6 minus x, divide that by log base 2 of 4. It's going to give us log base 2 of x. So we continue and say this is going to become log base 2 into 6 minus x is going to give us, divide that by log base 2. Now this 4 is the same as saying 2 squared. 2 squared is equal to 4. Is going to be equal to log base 2 of x. So that is the same as saying log of base 2 of 6 minus x, divide that by, now this 2 comes right there. So it becomes 2 log 2 base 2 to log of 2 base 2 is going to be equal to log base 2 of x. So we continue with our calculation. That will become log base 2 of 6 minus x, divide that by, now we said in our laws that any number, when you have a logarithm whose base and number are the same, that is equal to 1. So it's going to be 2 times 1, and that's going to be 2, is equal to the logarithm of 2 of x. So that will continue. When we multiply 2 on both sides, we'll end up with log of 6 minus x base 2, giving us 2 log x base 2. So by our law still, these 2 can shift to that power. When it shifts there, you will remain with log of 6 minus x is giving us log base 2 of x squared. Now what do we see here? Here we are seeing that you're having log base 2 on this side, log base 2 on that side. So it means that the values of those logarithms are the same. This value there should be equal to that value there, since this it's log base 2, log base 2. So here what we do is simply equate this to that, and we get our value of x. So it's going to become 6 minus x is going to be equal to x squared. So now we regroup that equation and we form a quadratic equation. This is going to become x squared. When this x goes that side, it becomes plus x. When this 6 crosses to go that side, it becomes minus x is equal to 0. So we form the quadratic equation. We find the sum and product of the roots. We end up with x plus 3 into x minus 2. Show that log of x base 8 is equal to 2/3 log of x base 4. So if you are to prove, you are going to start from this way. We are proving that this is equal to that. Where we are headed, it's in log. It's a log that has got base 4. So it means that we are going to convert this logarithm to base 4. So it's going to mean that log base 8 of x base 8 is going to be equal to, converting it to log 4 will be log of x base 4, divide that by log of 8 base 4. So if we continue with our calculation, that will be equal to log of x base 4, divide that by log base 4 of, now 8 here is as Emma is saying, 2 times 4. So from our laws, log of x base 4 is still going to be equal to log base 4 of 2 plus log of 4 also of base 4 actually. So when we continue, this is going to be log of x base 4, divide that by log of 4 of 2 base 4. This is when the base and the number are the same. This is equal to 1, so it's going to be plus 1. So this still will be log of x base 4, divide all that by, now let's convert this to base 2. This log is of base 4, we convert it to base 2, it's going to become log of 2 base 2, divide that by log of 4 is 2 squared base 2 plus 1. So that will become the logarithm of x base 4, divide that by log of 2 base 2 is 1 over, this is log base 2 of 2 is 2. When you put that 2 there, it's because it's also going to become 2, so this is a half plus 1. So it will become logarithm of x base 4, divide that by half plus 1 is 1.5, which is 3 over 2. And you find that log of x base 4 divided by 3 over 2 is the same as saying log of x base 4, that is 2 over 3. And from there we have proven our question. So now they are telling us the second part of the question is that hence solve log 8 base 6 if log base 3 of 4 is that of 3 base 4 is going to be equal to 0.7925. They want us to find the logarithm of 6 base 8. Now log of 6 base 8, remember, according to our earlier calculation, our earlier proof, is simply going to be 2/3. First of all, before we get here, they want us to find log of 8 base 6, and we are supposed to find that log deriving from our previous calculation. From our previous calculation, we have seen that log of 8 base x is going to be equal to 2/3 log of x base 4. So if they want us to find the log of 6 base 8, it simply means that the value of x now is 6. So we shall go ahead and substitute this 6 in this expression, and then we continue with our calculation. So here it's going to become, we know that log base 8 of x is equal to 2/3 log of x base 4. And now here the value of x we've been given is 6. So it's going to become log base 8 of 6, giving us 2/3 log of 4 base 6. Now we are supposed to tailor this number to ensure that we manipulate this logarithm so that within the expression we are having a log base 3 somewhere, because we are not supposed to use a calculator. We are supposed to use this information that log base 3 of 4 is 0.7925. so this logarithm here is the same as saying 2 over 3 log base 4 into, now 6 is the same as saying 3 times 2. So from there it is the same as saying 2 over 3 the log of log base 4 over 3 plus log base 4 of 2. If we continue like that, this is going to become 2/3 into logarithm of 3 base 4. Now we already have log of 3 base 4 from our question. It says that log of 3 base 4 is 0.7925. So at this point we simply substitute for that. But then we have this, and we're not supposed to use a calculator, but we're just supposed to find what it is. So log of 2 base 4, we convert this logarithm to base 2. So it's going to become log of 2 base 2, divide that by log of 4 base 2, like that. So that is going to become 2/3 into log of 4 base log of 3 base 4 plus log of 2 2 and 2, that's going to be 1, divide that by, now this is going to become log of 2, that is 2 squared. It's the same as saying 2 over 3 into the log of 4 3 plus 1 over 2 log 2 2. This 2 comes there from our laws of logarithms. So this becomes 2 over 3 into log of 3 base 4 plus 1 over, this is log of 2 base 2 is 1, so 1 times 2 is 2, like that. It's a half. So our calculation will be 2 over 3 into log of 3 base 4. From our question it is 0.7925 plus a half, and our final answer from that will be from 0.86167. That's the final answer we have. So let's look at the second example here. The second example here is asking us to prove that log of x base 6 is equal to log of 3, log of x base 3 over 1 plus log of 2 base 3. And it's also asking us to solve that given that log base 3, log of 2 base 3 is 0.631, find the log of 6 base 4. This is an example. It is similar to the previous one. Let's begin exploring it. So we are proving from this side log of 6 base x, which is that one. We are converting this. We are supposed to prove that this is equal to that. But if you look at whatever we are supposed to prove, everything here is in base 3. The logarithm is to base 3. So it means we shall begin here by converting this to base 3. So this is going to become log base 3 of x over log of 6 base 3. That's going to become log of x base 3, divide that by log of 3 into, now for 6, 6 is going to be the same as 2 times 3. Now remember, in whatever we are supposed to prove here, we already have this upper component now, log of x base 3. So now we are supposed to figure out, manipulate this to come up with that, and we will be having our answer. So far here we already have log of 3 base 2. So this is going to become logarithm of x base 3, divide that by log of 3 2 plus log of 3 3. We are getting this expansion from our laws of logarithms, so we shall end up with log of x base 3, divide that by log of 3 base 2 plus log of 3 base 3 is 1. So we have already proven the answer. So meaning that log x base 6 is going to be equal to log of x base 3, divide that by 1 plus the log of 2 base 3. So we have proven it. That is the answer now, because the question was asking us to prove that this is equal to that, and from our calculations as we have gone through, we have finally proven it. Of your screen, log of a base b is equal to x. Show that b is equal to a to the power 1 over x, and from that deduce that log of b base a is equal to 1 over log of a base b. So we shall start with the calculation. From here they are telling us that log of a base b is equal to x, that we deduce from this to show that b is equal to a to the power quarter x. So we are coming from here to go to there. So what we do, we convert this logarithm into an indice. So in this case it's going to become b to the power x is equal to a, like we had described in our earlier videos when we were introducing the laws of logarithms. So here it's going to become b to the power x is going to be equal to a. b to the power x is equal to a. So we remove this power of x by multiplying both sides by the power of 1 over x. So when you multiply 1 over x on both sides, 1 over x times x will leave us with b, giving us a to the power 1 over x. And hence we will have deduced that b is equal to a to the power 1 over x. The question goes ahead to tell us that we should deduce that this log of b base a is equal to 1 over log of a base b from this expression. So since we are coming from that expression, we are going to put log a on both sides of that expression. Why? Because if you look at the expression that we have been told to deduce, there is log a throughout. So meaning that if we are coming from this indice here and we are to deduce this expression, we are simply supposed to multiply by log base a on both sides. So here it's going to become log base a to the power log of b base a is going to be equal to log of a to the power a quarter to the base a. So it's going to become log of b base a, giving us this 1 over x comes there from our law of logarithms. So it's going to become 1 over x log of a times a. So here we shall have that log of b base a is going to be equal to 1 over x, and we shall end up with x giving us 1 over log of a base b. But now what is x? According to the question, x is equal to log of a base b. So we substitute for the value of x there. So when we come down here, we substitute, and the value of x is going to become log of a base b, which is going to be equal to 1 over log of b base a. So here actually if we interchange, it's going to become log of b base a is going to be equal to 1 over log of a base b. And so we have deduced, and as a result we have answered the question. Let's do the next example. Without using tables or calculator, show that this log of root 27 plus log of root 8 minus log of root 125 over log of 6 minus log of 5 is equal to 3 over 2. Without using tables, without using a calculator. So we begin. Log of root of 27 is the same as the logarithm of, now 27 is the same as 9 times 3 plus log root of 8. Remember, when it is just log, when they do not show the base at the bottom, they do not show the base, we simply, that means it is log base 10. So this is log base 10 under the root of 9 times 3 plus log base 10 of, now what is 8? 8 is the same as 2 times 4. That is minus log base 10 of, what is 1 to 5? 1 to 5 is the same as 5 times 25. And all that is, we are dividing it by the log of 6 minus log of 5, like that. So log of 6 minus log of 5, we continue. This is going to become, now this we're supposed to work out and make sure that whatever manipulations we are going to make here should give us a final answer of 3 over 2. When the manipulations we do in this calculation give us 3 over 2, we will have shown that this expression is equal to 3 over 2. So we continue. That's going to become the logarithm of, now root 3 is 3. And the root of, the square root of 9 is 3. So it's going to be logarithm of 3, root 3, plus, that is going to be the logarithm of, now the square root of 4 is 2. So it's going to be 2 times the root of 2. So it's log of 2 times the root of 2 minus the square root of 25 is 5, so it's going to be minus the logarithm of 5 times root 5. All that is, we are dividing that by, now log of 6 minus log of 5, from our law of logarithms, it's going to become the logarithm to the base 10 of 6 divided by 5. We continue with our manipulations. Now this is this log of 3 root 3 is the same as saying log of 3 times root 3. This is log of 2 times root 2, and this is log of 5 times root 5. From our law of logarithms, this is the same as saying log of 3 plus log of root 3, log of 2 plus log of root 2, and log of 5 plus log of root 5. From our laws of logarithms, we've explored that in the beginning. So we continue. It's going to become log of 3 plus the log of root 3 plus log of 2 plus log of root 2. That's going to be minus log of 5 plus log of root 5, like that. Log of root 5. We're dividing all that by the log of 6 over 5, like that. So now we regroup them. Those logarithms that are having whole numbers, we clamp them alone, and those ones that are having roots, we shall just clamp them alone too. So this is going to become the log of 3 plus the logarithm of 2. This is minus log of 5 plus log of root 3 plus log of root 2. This is minus log of root 5. All that divided by log of 6 over 5. So we continue. This is going to become, when we add log, add and subtract, this is going to be, it's log base 10, log base 10, log base 10. We group it together using our laws of logarithms. Log base 10, this is going to become 3. This plus this means it's 3 times 2 from our law of logarithms. And since this is minus log 5, so it's going to become divided by 5 over 5. We shall add that to the log in brackets, that is root 3 times root 2, root 3 times root 2. Why do we multiply? Because this is addition of logs. So from our law of logarithms, we are going to multiply the the numbers, and since it's minus root 5, so it's going to be divided by root 5. All this, divide that by log of 6 over 5. So when we continue, it's going to become a log of 3 times 2 is 6 over 5 plus log into, now root 3 times root 2, from our law of indices that is sometime back in our previous videos, 3 times 2 is root of 6, so it's going to become the square root of 6, divide that by the square root of 5 over, that is going to be log of 6 over 5. So we continue, it's going to become the logarithm of 6 over 5 plus the logarithm of, now root of 6 over root of 5 is the same as the square root of 6 over 5, and square root of 6 over 5 is the same as 6 over 5 to the power half. So it is the same as saying 6 over 5 to the power a half, divide all that by log of 6 over 5. So we continue, it's going to become log of 6 over 5 plus this a half, multiply it there, it's going to become a half. From our laws of logarithms, this a half is brought here, times a half log of 6 over 5, divide all that by the logarithm of 6 over 5. So we shall end up with, if we are to split this, it's going to become log of 6 over 5 over log of 6 over 5 plus a half log 6 over 5 over log 6 over 5, like that. From there we shall get this and that cancel, so you remain with 1 plus this and that will cancel, you remain with a half. So a half plus 1 is going to become 1 and a half, and which is going to be 3 over 2. So after getting our 3 over 2, we've indeed shown that we have proven our point. We have proven what we've been told. We've been told to prove that this is equal to 3 over 2. And from calculating from this side, we have gotten our final answer as 3 over 2. So after getting our answer as 3 over 2, that marks the end of this video. Consider this a continuation of this topic, logarithms, as we discuss equations involving exponents and exploring how the laws of logarithms and indices are used in solving such equations. Part A right there is telling us, you see, 5 to the power 2x minus 5 to the power x plus 1 plus 4 is equal to 0. 5 to the power 2x minus 5 to the power x plus 1 plus 4 is giving us 0. 5 to the power 2x is the same as saying 5, that's to the power x to the power 2, because 2 times x is 2x. That is coming from our law of logarithms. 2 times x is 2x, minus 5 to the power x plus 1 came from 5 to the power x, multiply that by 5 to the power 1. Because when you multiply 5 to the power x times 5 to the power 1, the base is the same, so the powers were added. All this is coming from our law, the laws of indices. Even this x times 2, these are laws of indices we are applying here. We covered the laws of indices in depth in an earlier video from this one. Plus 4 is equal to 0. So from this we shall say that let m be equal to 5 over x, or let 5 over x be equal to m. So we substitute for m where there is 5 over x here to obtain a simpler expression to handle. So this is going to become m squared minus 5m plus 4 is equal to 0. So there we have formulated a quadratic equation in m. So we solve the quadratic equation, finding the sum and product, sum of negative two numbers giving us the sum of negative 5 and product of positive 4. We will end up prime factorizing the equation, having m minus 1 into m minus 4 is equal to 0. So the answer is that either m minus 1 is equal to 0 or m minus 4 is equal to 0. So here m is going to be equal to 1 or m is going to be equal to 4. Those are the answers we are getting. But remember, we said that this m is equal to 5 to the power x, and we're interested in finding x. So we substitute for m in this expression and say 5 to the power x is equal to 1 here, and there 5 to the power x is equal to 4. So after introducing that like that, we introduce logarithms on both sides. Here the log of 5 to the power x is going to be equal to the log of 1, and even here we say log of 5 to the power x is equal to the log of 4. Remember that this is log base 10. With log base 10, the standard base is 10 and we don't have to put the 10 there. It is optional to put it down there. Any number to the power 1, in this case, any number to the power 0 is always equal to 1. So it means that here this 5 to the power x is equal to 1. But we know that this 1 can be expressed as any number to the power 0 is equal to 1. So if this 5 to the power x is equivalent to 5 to the power 0, that means we would not need this step. 5 to the power x is equal to 5 to the power 0, because 5 to the power 0 is 1. So meaning that when you the bases are the same, 5, 5, so the value of x here is 0. That's the first value of x. X can be 0 or it can be something else. If we consider this side here, 5 to the power x is equal to 4, we introduce log base 10 on both sides. So log of 5 to the power x is equal to log base 10 to the of 4 to base 10. So this x comes down here, it becomes x log 5, giving us log 4. So this is going to become, our value of x here will become the log of 4 over log 5. And so if you punch that into our calculator, log of 4 base 10 over log of 5 base 10 is going to give us 0.861. And that is our answer. So we shall go to part B of the question. Part B of the question is 3 to the power 2x plus 1 minus 26 to the power 26 times 3 to the power x minus 9 is equal to 0. And even there, we are supposed to find the value of x. So we start breaking down the number. So it's going to become 3 to the power x there. To the power 2, because 2 times x is 2x. That is, since it's 3 to the power 2x plus 1, let's go very slowly here. It's going to become 3 to the power 2x times 3 to the power 1. 3 to the power x squared times 3 to the power 1 minus, this is going to be 26 into 3 to the power x minus 9 is equal to 0. So we shall say that let 3 to the power x be equal to t. So we shall substitute t where there is 3 to the power x, and we shall end up with t squared. This is 3 to the power 1, so it's going to be 3t squared minus 26t minus 9, giving us 0. So we have a quadratic expression there in terms of t. So when we find the sum, two numbers giving us the sum of negative 26 and the product of 9 times 3, which is 27, we shall end up with prime factorizing that quadratic expression as 3t squared minus 27t plus t minus 9 is equal to 0. From there we shall end up with 3t plus 1 into t minus 9 being equal to 0. So here either t is going to be equal to a third or t is going to be equal to 9. But we know that this value of t is equal to 3 to the power x. So we know that 3 to the power x is going to be a third, or 3 to the power x is going to be equal to 9. So from there we start simplifying it further to get the value of x. And in both cases we shall introduce logarithms on both sides. This is negative, by the way, because when 3t plus 1 is equal to 0, t is going to be negative a third. T minus 9 is equal to 0, t will be equal to 9 when you make t the subject of the formula. So introducing log on both sides, we have log of 3 to the power x being equal to log of negative a third. That is going to become x times the log of 3 is going to give us log negative a third. So x here is going to be equal to the log of negative a third, divide that by the logarithm of 3. But the log of a negative number does not exist. So because it does not exist, we shall ignore this value of x. So we ignore this value of x, and so we consider this one. So let's go ahead and put log on both sides for this value of x. Putting log on both sides here is going to become log of 3 to the power x is equal to log of 9. When that x comes here, from our laws it becomes x log of 3 is equal to log of 9. So x here is going to become the logarithm of 9, which is 3 squared, because 3 times 3 is 9. Log of 3 squared, divide that by the log of 3. So our value of x here is going to become 2 log 3, divide that by the log of 3. So we shall end up with that log of 3 cancels out with that one. We end up with our value of x as 2. That is part B of that question. So let us answer the final question, part C of the question. Part C of the question states that 4 to the power 2x plus 1 times 5 to the power x minus 2 is going to be equal to 6 to the power 1 minus x. So finding the value of x there, let's introduce logarithms on both sides here. So this is going to become the log of 4 to the power 2x plus 1. Since it is multiplication here, it means it's going to become plus the log of 5 to the power x minus 2 is going to give us the log of 6 to the power 1 minus x. So now we remove all these powers. This power comes before this log. This power is transferred to that log. This power is transferred to that log. Remember, for us to shift from here to here, we are manipulating the rules of logarithms, that when you add two logs with the same base, you simply add the terms. I mean, you multiply the terms. This terms times that term. Okay. So now this is going to become 2x plus 1 log 4 plus x minus 2 log of 5 is going to be equal to 1 minus x the log of 6. So we shall continue with our calculation there. 2x times that, this is going to become 2x plus 1. What is the log of 4? When we punch that in our calculator, we get 0.6021 plus x minus 2 times the log of 5. What's the log of 5? The log of 5 is 0.699. Is going to be equal to 1 minus x times the log of 6, which is 0.778. So we proceed. 2x times that figure is going to become 1.2042x. This times that is going to become plus 0.6021 plus x times that is going to be 0.699x. This times negative 2 is going to become negative 1.398. 1.398. That is going to give us this times that, which is 0.778. Then this times that is minus 0.778x. So the answer, when we collect like terms, we shall end up with 1.204x plus 0.699x, which is that one. Then we have this x also coming this side of the equation, which is going to become plus 0.778x, giving us 0.778 minus 0.6021 plus 1.398. This 1.398 process the equal signs, it becomes a positive here. So the value of x we get here is going to become 0.587. Solve the simultaneous equations below. We are having this equation and that equation, and we are to solve them simultaneously. Using the knowledge we explored in our earlier videos about the laws of indices, we know that 5 to the power x plus 2 is equivalent to 5 to the power x times 5 to the power 2. 7 to the power y plus 1 is equivalent to 7 to the power y times 7 to the power 1. That is all from the knowledge we explored before in our earlier videos regarding the laws of indices. This is all going to be equal to 5468, and that is going to make our equation 1. Our equation 2 is going to be 7 to the power y is equal to 5 to the power x minus 76. So from there, let 5 to the power x be equal to m and 7 to the power y be equal to n, so that we are able to obtain two simultaneous equations that we can easily manage to solve. So it means that our first equation is going to become 25m plus 7n, because 7 to the power y is n, is going to be equal to 5468. So our value of n here, and then the second equation will become 7 to the power y is n. So it's going to be n is equal to 5 to the power x, which is m, minus 76, and that's our equation 2. So these are our two equations. We are going to solve them by substitution. By substitution, I mean we are going to get the value of n, which is m minus 76, and substitute it in the first equation. And our first equation here is 25m plus 7n is equal to 5468. So when you substitute the value of n in this first equation, it's going to become 25m plus 7 into the value of n, which is m minus 76, is going to be equal to 5468. We go ahead and open those brackets. We get 25m plus 7 times m is 7. 7 times negative 76 is negative 532. Is going to be equal to 5468. 25m plus 7m gives us 32m, and then this crosses the equal signs and goes that way. Here it was a positive, a negative. When it crosses the equal signs to come to this side, it becomes a positive. So we have 5468 plus 532. We end up with 32m giving us 1068. Then when we divide both sides by 32, we get our value of m as 187.5. So after getting the value of m as 187.5, we then now find the value of n. Our value of n is going to become m minus 76, which is going to be 187.5 minus 76. We are getting this equation from one of these equations here, m minus 76. This is the value we are substituting in, the value of m. So you substitute this value of m into this expression, and we get our value of n there as 111.5. So we now know that m is 187.5 and n is 111.5. But then, remember we said that we had substituted m is equal to 5 to the power x and n is equal to 7 to the power y. And looking at our question, we are not interested in finding the value of m or the value of n. We are actually interested in finding the values of x and y. So for us to get these values of x and y here, this is the same as saying 5 to the power x is going to be equal to m. What is m? M is 187.5. 187.5. Even here, 7 to the power y is going to be equal to our value of n. What is our value of n? 111.5. So what we do here, we introduce log base 10 on both sides. So this becomes log of 5 to the power x is going to be equal to the log of 187.5. So from our law of logarithms, this value of x comes there. It becomes x log of 5 is going to be equal to log of 187.5. So our value of x here is going to be the log of 187.5, divide that by log of 5. And what is our answer there? Log of 187.5 divided by that, we get one of the values of x as 3.252. This is one of our values of x. We come here to get the value of y. We are going to do the same thing like we've done here. We introduce log on both sides. So it becomes log of 7 to the power y is going to be equal to log base 10 of 111.5. When this y comes here, it becomes y times the log of 7, giving us log of 111.5. So our value of y here is going to become the log of 111.5, divide that by the log of 7. So our value of y here is going to become 2.423. 2.423 now is our answer. And our value of y, and here this is the value of x. So now let's do one more example. In that example, we are being asked to solve for those two simultaneous equations, find the value of x and find the value of y. Those are two logarithmic equations. So we go straight away and start manipulating. We are supposed to simplify these equations into manageable forms. If you look at this first equation, it is to base 3, this is base 27. The second equation is to base 9, here it is to base 3. So in both these two simultaneous equations, we see that 3 is the lower base. So it means let us resolve to change everything to base 3. So in this case, this is going to become this equation 6 times the log base 3 of x plus 6 log of y base 27, that is going to be equal to 7. So we convert that to log. We convert it to base 3. So this is going to become 6 log of x, that is base 3, plus 6. Now we convert this to base 3. So it's going to become 6 log base 3 of y over log base 3 of 27 is going to give us 7. So we shall end up with 6 log 3 base x plus 6 log 3 base y. Divide that by 27 is when you prime factorize 27 here, let's do some side work here. This is 7. 27 by 3 we have 9, by 3 we have 3. So it's 3 to the power 3. So it's going to be log base 3, 3 to the power 1, 2, 3. That is going to be equal to 7. So we continue, it's going to become 6 times the log base 3 of x plus 6. Now this is going to give us 3, because when this 3 comes down here, it's going to become 3, log 3, 3. So it's going to become 6 over 3 log 3 log of y base 3 is equal to 7. And of course here our equation will become 6 times the log of x base 3 plus 2 log of y base 3 is equal to 7. So now there we have simplified our equation. Let's call that our equation 1. So we have manipulated this equation, we have simplified it, and we have made sure that all the terms with logarithms are to the base 3. So we are going to do the same to this second equation. And so it means you are going to convert this term log base 9 into log base 3. So we continue with our calculation for the second case. So the second case shall be for log. We are starting with the second equation. The first case, it is log x base 9. So we are converting it to base 3. So it's going to become log base 3 x over log of 9 base 3. That is going to add plus 4 log y of 3 plus 4 log y base 3 is going to be equal to 9. So we proceed and say this is going to become 4 log x base 3, divide that by log of 9 is 3 squared, so it's 3 squared base 3 plus 4 the log of y base 3 is equal to 9. What do we come up with? This becomes 4 log x 3, divide that by this 2 comes down here, it's going to become 2 log of 3 base 3 plus 4 the logarithm of y base 3 is equal to 9. So we end up with 4 the log of x 3 over, this is going to become 1, so it's 1 times 2, which is 2, plus 4 log of y base 3 is equal to 9. So we continue the calculation by 2 once, by 2 twice, so it's going to become 2 log x base 3 plus 4 log of y base 3 is equal to 9. That is our second equation. So after modifying our two equations into the first equation, the second equation, now we are supposed to simplify them. Let's first analyze the two equations. The first equation is 6 log 3x plus 2 log 3y is equal to 7. That's the first equation. And the first equation, we got it. It's this one. I've just recopied it. Then the second equation is 2 log 3x plus 4 log 3y is equal to 9. That's our second equation. So now, how do we solve those two simultaneously? Let us simplify their look. Let's say, let the log of 3 base x be equal to m, and the log base 3 of y be equal to n. So where there is log of x base 3, we substitute m. Where there is log y base 3, we put there n. So it means that our equation 1 is going to become 6m plus 2n is equal to 7. That's one of them. Then our second equation is going to become, this is log base 3x, so that is 2m plus 4n is equal to 9. So now we solve these two equations simultaneously. When we solve those two equations simultaneously, we shall end up with values of m as, the value of m we shall get when we solve those two equations simultaneously. M will be equal to 1/2, and our value of n will be equal to 2. So now when m is 1/2, then we now bring back the logs, the log issues. Now we say that our value of m is log 3 base x. For us, we are interested in finding the value of x, not the value of m. Okay? So in this case, if m is equal to 1/2, it means that the log of x base 3 is going to be equal to 1/2. And in this case, we know that to find the value of x, we simply employ the law of indices, where we know that 3 to the power 1/2 is equal to x. So in this case, it's going to become 3 to the power 1/2 is going to be equal to x. And we know that 3 to the power 1/2 is the same as saying the square root of 3. So one of the value of x is the square root of 3. And that's the answer. So now let's try and find the value of n. We find the value of n still by substituting the value of n here. We know that n is log of y base 3. So log of y base 3 is going to be equal to the value of n, which is 2. Still, we are going to use our law of indices, where 3 to the power 2 is equal to y. This is when we are converting a log into an indice, or into an index. So it's going to be 3 to the power 2 is equal to y. So y 3 squared is going to be 9. So meaning that our value of y is going to be equal to 9. So we've gotten our value of x, we have gotten our value of y, and we have been able therefore to find the values of x and y in a logarithmic expression with two unknowns. The first example here is showing, it's asking us to show that log x times y base 16 is equal to that expression. And after showing that or proving that, we are asked to solve the pair of simultaneous equations that you're seeing below there. So we begin off. We're supposed to show that this is equal to that. So we start from this side. Log xy base 16 is going to be, where we are headed, everything is to the base 4. So meaning that we are going to convert this logarithm from base 16 to base 4. So that is going to be equal to log xy base 4, divide that by log xy base 16. Base 4, that is 16 here. So that will be log of x times y, base 4, divide that by log 4 squared base 4. So from our law of logarithms, log of x times y to the power 4 is the same as saying log base 4 of x plus log of y base 4. Divide that by, now when this 2 comes here, it's going to become 2 log of 4 base 4. So to continue with our calculation, this is going to become log of x base 4 plus log of y base 4. Divide that by, when the number and the base are the same, this becomes 1. So log of 4 base 4 is 1. So it's 1 times 2, and we are going to have 2 there. So we finally get our expression. This is going to turn out to be a half the log of x base 4 plus a half the log of y base 4. And there we will have shown this is equal to log 16 base 16 of xy. So just like our question was demanding that we show that this is equal to that, we have indeed showed it. So that's our answer. So from there we're supposed to solve the pair of simultaneous equations that has been given to us. And the pair of simultaneous equations, I will rewrite it here. It is log of xy base 16 is equal to 3.5. And also log of x base 4, divide that by log of y base 4 is equal to -8. So from this pair of simultaneous equations, we know that this log base 16, as we are seeing here, is equivalent to that whole expression that we have just shown. So we modify our first equation and it becomes a half the log of x base 4 plus a half the log of y base 4 is going to be equal to 3.5. That is our equation 1. Then also the second expression here is going to be the log of 4 log of x base 4, divide that by log of y base 4. This is going to be equal to -8. That is our second expression. So from the expressions above, we see that in the first expression we are having logarithms that are all to the base 4, both in the first and the second expression, only that in the first expression we have logarithm of x base 4 and logarithm of y base 4. In the second expression we have logarithm of x base 4 and logarithm of y base 4. So to obtain an easier to deal with kind of expression, we shall say that let m be equal to the log of x base 4 and let n be equal to the log of y base 4. So we shall substitute where we have log base x of 4, we put there m. Where we have log of y base 4, we put there n, and we obtain new expressions. So in this case, for our first expression is going to become a half m plus a half n is equal to 3.5 is 3 times 2 is 6 plus 1, that is 7 over 2. That is the expression we get. So now if we multiply through by 2, we are going to end up with m plus n is equal to 7. That is, if we multiply through by 2, by 2, by 2, we shall end up with m plus n is equal to 7. And that's going to be our new expression. Then we get to this other expression. This is going to give us log of x base 4 is m, so it's going to be m over log base y base 4 is n, so m over n is going to give us -8. So we shall end up with m giving us -8n. That is our new second expression. From this we've come up with that. So now we deal with this and that. These two simultaneous equations, we solve them to find the values of m and n. And so here by substitution, if we substitute for the value of m in the first equation, we shall have m is negative 8n. So here it is negative 8n. As we are substituting here, it's going to be negative 8n plus n is going to give us 7. So what do we have here? Negative 8n plus n is going to give us negative 7n, giving us 7. Divide both sides by negative 7. Divide both sides here by negative 7. This goes with that. You remain with n as negative 1. So our value of n is negative 1. So let's find our value of m. We know that value of m is negative 8n. So it's as simple as saying m is going to be equal to negative 8 times n, which is negative 1. And that is going to give us 8. So our value of m is 8. Our value of n is negative 1. But we are not interested in getting the values of m and n. We are interested in finding the values of x and n. But we know that n is equivalent to the log of y base 4. And we also know that n is equal to negative 1. So it means that this expression is going to be equal to negative 1. So we convert that into indices to find the exact value of y. So we say it is going to be 4 to the power negative 1 is giving us y. So it's going to be here 4 to the power negative 1 is going to give you y. So we end up with y giving us 1 over 4. So our value of y is a quarter. So what about our value of m? We know that our value of m is equal to the log of y. Our value of m, according to our previous steps, it's going to be equal to the logarithm of x to the base 4. So it is what we shall be filling here. M is going to be the logarithm of x base 4. But we know that this value of m, we got 8. So this is equivalent to 8. Still, we are going to convert that log into an index. So it's going to become 4 to the power 8 is equal to x. Just like the way we were doing in our previous videos when we were exploring the law of indices. So this is going to become 4 to the power 8 is going to be equal to x. And I think that's the answer. X is going to be equal to 4 to the power 8. So our value of x is 4 to the power 8, and our value of y is a quarter. So let's do our next example. Our next example, the question is right there. If the logarithm of x base 2 plus the logarithm of x base 4 is equal to 21 over 16. Solve for the value of x. So we shall start straight away with solving the value of x there. So here we are going to convert everything to base 2, because this is a logarithm to base 2, this is a logarithm to base 4, this is a logarithm to base 16. So we convert all these logarithms to one base, preferably the lowest. So we are going to convert it to base 2 so that it becomes easier to deal with. So in this case, it's going to become the logarithm of x base 2 plus, convert this to base 2, it's going to become the logarithm of x base 2, divide that by the logarithm of 4 base 2 plus the logarithm of x base 2, divide that by the logarithm of x base this is the logarithm of 16 base 2. This is 16. It's going to be giving us 21 over 16. So to continue with our calculation, this will become log of x base 2 plus log of x base 2, divide that by the log of, this is 4 is 2 squared, so it is 2 squared base 2 plus the logarithm of x base 2, divide that by the log. Now 16 is 2 to the power 4, because 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So it is 2 to the power 4 base 2 is going to be equal to 21 over 16. So we continue, it's going to become log of x base 2 plus log of x base 2, divide that by, now this 2 comes here, so it becomes 2 log of 2 base 2 plus, that is log of x base 2 over this 4 comes there from our laws of logarithms, so it becomes 4 log of 2 base 2 is giving us 21 over 16. So to continue, this becomes log of x base 2 plus log of x base 2, divide that by, this is 2 times 1, because from our law of logarithms we know that when the number and the base are the same, it means that is equal to 1. So the log of 2 base 2 is equal to 1. So 1 times 2 is going to be 2 plus log of x base 2, divide that by, this is 4 times 1, which is 4, is giving us 21 over 16. After obtaining that expression, let us codename log of x base 2. We give it a letter. So we shall say that let the logarithm of x base 2, let it be equal to y. So if it is equal to y, it means that our expression is going to change. This is going to be y plus half y plus a quarter y is equal to 21 over 16. So that is going to, we now simplify this expression and get our value of y. If we are to multiply through by 2, this times 2, let's do it practically. If you multiply here by 2 here, actually let's multiply through by 4, because 4 is the highest in the denominator. If you multiply through by 4, we shall end up with 4 times that is 4y plus by 2 ones by 2 2, so it's going to be plus 2y plus by 4 ones by 4 ones, that is plus y is going to give us by 4 ones by 4 4, so it's going to become 21 over 4. So once it becomes after it has become 21 over 4, 4 plus 2y plus y is equal to 21 over 4. We multiply through by 4 to make it a flat equation. So we multiply this here by 4, by 4, by 4, by 4 throughout to make it a flat equation, so that this 4 and that 4 cancel out. Here we shall remain with 16y plus 2 times 4 is 8y plus 4 times y is 4y, is giving us 21. So this, adding all that up, is going to end up with 28, y giving us 21. When you divide both sides by 28, we shall end up with our value of y as 3 over 4. But we are not interested in the value of y, because y is log of x base 2. We are interested in the value of x. So for where there is y, we substitute for it with that logarithmic expression. So where there is the value of y, we shall say that the log of y of x base 2 is going to be equal to 3 over 4. And from here we shall employ the law of indices, whereby this 2 to the power that expression is going to give us that value of x. So it's going to become x is going to be equal to 2 to the power 3 over 4. And so that is going to be our value of x, and that is going to be the final answer.